Here are solutions for perfect problem 4 from Math 65. We're asked to divide these polynomials, and the little hint is that you should get the same answer. What makes this problem a little bit tricky, or maybe one of the things, is that at this point in the class we don't know how to divide a polynomial by a polynomial. We only know how to divide a polynomial by a monomial. But it turns out that we can turn this problem into that problem. If we just leave the top alone, negative 300 x to the 10th y to the 10th minus 33 xy to the 10th plus 3 x squared y squared plus 6xy squared. And then on the bottom, if we collect like terms, combine like terms, we got negative 1 of these xy squared things, and I want to subtract 2 more of these xy squared things. That leaves me with negative 3 of these xy squared things. And then what I can do is I can break this up term by term. My first term is negative 300 x to the 10th y to the 10th divided by negative 3xy squared. And my next term is negative 33 xy to the 10th divided by negative 3xy squared. I left this as plus negative because I knew my denominator was negative, so I'd cancel those out later. But you could write it different also. Next term I got 3x squared y squared divided by negative 3xy squared. And then finally I got 6xy squared divided by negative 3xy squared. And now all I have to do is reduce each of these four terms. Negative 300 divided by negative 3 is positive 100. X to the 10th over x to the 1 is x to the 9th if you subtract the exponents. Y to the 10th over y squared is y to the 8th. And then this next one, these negatives cancel out. Negative 33 over negative 3 is just positive 11. X's cancel, and we're left with y to the 8th power. And then over here, a positive divided by a negative is a negative. 3 divided by 3 is 1. X squared over x is just x. This is x squared divided by x to the 1. And the y squareds cancel out. We're left here. Then finally, positive over negative is a negative. 6 over 3 is 2. X and x cancel. Y squared and y squared cancel. Left with this is our final answer. So what we now have to do is repeat that on this guy and hope we get the same answer. And similar to the first one, we can turn this into a problem that we can handle, specifically a polynomial divided by a monomial. If we leave the top completely alone and combine like terms on the bottom. So down on the bottom here, I got 5x cubed, 5 of these things, minus 1 of these things. That gives me 4 of these things. So then what I can do is break it up term by term just like I did before. 400 x to the 12th, y to the 11th, divided by 4 x cubed, y cubed. Maybe minus 8 of x cubed, y cubed, divided by 4 x cubed, y cubed, minus 4 x to the 4th y cubed over 4x cubed y cubed, and finally plus 44x cubed y to the 11th over 4x cubed y cubed. Now if I reduce each of these, 400 divided by 4 is 100. X to the 12th over x cubed is x to the 9th, and y to the 11th over y cubed is y to the 8th. And sure enough, that matches with this term. Okay, this one I got minus 8 divided by 4 is 2. X cubed, those cancel. Y cubed, those cancel. I got minus 2. Same thing I have over here. Over here, I got negative. 4 over 4 is just 1. X to the 4th over x cubed is x to the 1 power, or just x. And the y cubes cancel. Got minus x just like I have here. And finally, 44 over 4 is 11. X cubed over x cubed cancels. Y to the 11th divided by y cubed is y to the 8th. And if you really wanted to, you could write this in a different order to really emphasize that we got the same answer on the top and on the bottom. This is the same as this. Throw a little check mark. Call that the end of this perfect problem.